installed and removed, and potentially by whom. Yum history will return that. So returns usage history. And this is IE, like the bash shell history, which is queryable and can be quite useful, especially for auditing purposes, to determine what's changed on your system. So let's look at the Yum history to see what's occurred thus far. And here we see the various actions. Reinstall, install, reinstall, so on and so forth. And it's all been logged with the various timestamps. And of course this should be root who performs these particular steps. Which leads us to another point. Supposing you wanted to be able to remove the packages recently installed. Of course, just like with RPM, you can. Remember, the key with Yum is that it's streamlined. It's a wrapper to RPM, which allows us to auto-resolve dependencies. So it does everything RPM does and then some. So supposing we wanted to remove these packages, just use the erase option. So Yum erase, Unix to DOS, for example. Which begs the question, can we specify both packages? So Unix to DOS, DOS to Unix, which are two distinct packages. And of course, this will prompt us for the yes option. But first, let's see how Yum handles a list of items. And notice it knows that two packages are to be removed because we indicated them separated by spaces. And here are their sizes, and we're prompted. Now, what about the assume yes option? Let's say it's not okay, and let's say we want to intervene with the assume yes option on an erase. So notice in this case, it's erasing the packages without prompting us. So both packages have been removed. Let's just include in our notes that if you include the yes option, it works here as well. It doesn't always work, but it works most of the time. So assumes yes and removes both packages. Which means, of course, if we try to search or use RPM to search our database for either DOS to Unix or Unix to DOS, nothing's there. So it's been removed from our system. Both can be specified as well on the same command line. Now, supposing you wanted to be able to see the dependencies of a package, there's an option for that as well. And that's Yum dep lists or dependency lists. So supposing we're not clear about how to install, let's say LFTP, which is currently installed, and we'd like to see a list of dependencies. So we simply indicate LFTP, one or more packages, and dependencies and their providers are returned, which is key, because this tells you which package provides what's needed by a given package. So we know LFTP needs certain things, like most packages do, in order to succeed. Well, Yum, because of its database layout, will return that information to you and save you time. So let's dep list LFTP, and this dumps a lot of items. So it needs libredline, which is provided by Redline, this package for i686, this version for EL6. It needs libtinfo, and Curses provides that. libc, glibc, and others. So for example, it needs the shell, and that's provided by bash. It needs GCC, provided by GCC. TLS, for transport layer security. That's provided by GNU TLS. So this particular option, which shows the dependencies, is important because it helps you to determine what needs to be installed and whether or not you should install it before installing it. Again, if you try to install a program and there's an unmet dependency, then Yum will resolve it for you. But at least with dep lists, you can see what those dependencies are and then make a decision as to whether or not you'd like to have the package install. Now, suppose you wanted to install a package directly from the file system, from the local system. Just like with RPM, you can do it with Yum. Again, it's a wrapper. So Yum, local install, and the name of the package. Let's get a path, let's say to DOS to Unix. We know it's in var www.html RHEL-6, and we'll take its full path. In fact, we're in the directory, so we'll just Yum local install DOS to Unix. and this will go through the process. Now of course it'll prompt us, so let's include to assume yes, so we're not prompted to install it. And it'll install it for us momentarily, and now it's available on the system, which DOS to Unix. So you can install locally as well. The same is the case with RPM. If you RPM UVH and the path to a local file such as the current directory Unix to DOS, it'll take it just as it'll take an HTTP URI. So you can install always from the local file system. Local install DOS to Unix, for example, will do the trick, and we should specify the full name. If you don't specify the full name, then let's show you what happens. Let's do a yum erase DOS to Unix, for example. And this will prompt us, will indicate yes momentarily. And now DOS to Unix is removed from the system. So we'll use the yum local install option, but neglect to specify the full file name. And that's this option. So let's take off the version information and platform information. And notice it's not able to find it. Because it's a wrapper, it's searching for, when you pass the local install option, the name of the file. So you need to specify the full name of the file, which in this case is DOS to Unix and its full version. So let's copy that and paste it into our notes, because it is important, because it is how RPM will allow you to install a file from the local file system. Let's just note the entire file name is indicated, because otherwise it won't install. But if you're using a standard installation, so let's yum erase DOS to Unix and Unix to DOS. And if we reinstall using yum install, so once this is completed, we'll yum assume yes and then install DOS to Unix, Unix to DOS. So in this case, we're specifying the package names, sans their suffixes, and a query of the database is performed, and all resolution is taken care of for us. So we've set up our first client as a yum client. And of course, we could set up the other server as a yum client, so it's able to find its files in the appropriate location. In fact, let's boot it up and get it going there as well, because ideally in your production environment you'll have perhaps one or two repositories within your network, perhaps on a DMZ somewhere, protected, and you'll simply provide repository files to the distinct Red Hat Enterprise client servers. So that brings us to another task, and that is to define Linux CBT Serv1 as a yum client, which also means they can be servers and clients of each other. So we could, for example, define Linux CBT Serv1 as a yum server as well, with the same path, and then point clients to both repositories so that yum knows how to find it. So that stretches our thinking and implementation a little bit, so we'll define that as the 6 tasks. So 6, define Linux CBT Serv1 as a yum server, which means we'll need to mirror the content from our Debian box. So we will use LFTP to connect to, let's pull the path from above, and it should be up here, so we'll take this full path and then we'll run a mirror. So we want these 2 tasks to occur on Linux CBT Serv1, and that way we'll have redundancy with respect to our yum server. In the event that one is down, then our yum clients will have 2 repository files and be able to get packages from either. And we can test that by stopping Apache, for example, on one and seeing whether or not yum is still able to carry out its tasks. So let's do this first. We'll make, because the synchronization takes a little bit, so let's define this as the 6th task and the synchronization as the 5th task. So let's ready this particular file, and as soon as the server comes up, let's send some packets to it. We will connect to it using SSH, and it's not yet up, so we'll just give it a moment. So the idea here is to define an additional server, and let's just note this configuration will provide Yum server redundancy via 2 repo files per Yum client. So if one is down, the other one will service it. And we're still waiting for this box to come up so that we can make a move. So we're going to synchronize all of these things, then we will, through the mirror process, then we'll create repo once it's in the directory var www.html. In fact, we could even copy the entire repo data structure as it is on Linux CBT Serve 2 because they are identical. It's the same set from the same DVD, so we wouldn't have to rerun create repo, but it's a short process. It doesn't take too much time, so it's not terribly arduous. So let's copy these 2 tasks because we also need to confirm that create repo is available, and this will become C and D, and then run create repo against the same directory structure, and then define Linux CBT Serve 1 as a Yum client of Linux CBT Serve 2. And then our 7th task, let's just intersperse it here, will be to define Linux CBT Serve 2 as a Yum client of Linux CBT Serve 1, of course via repo files. Now by now our server should have come up, and we're pinging the wrong IP. No wonder it's not responding. In fact, it is the right IP, it just hasn't received a response as yet. So let's give this a moment to come up. It should be up shortly. So let's see if it's up by now. And indeed, we've got some packets. So let's clear screen and begin setting up our environment. So again, we want to mirror the content from our Debian box over and then create a repository. So let's take this LFTP string and ensure that it's in memory. We also need to be sure that LFTP is installed, but it's usually installed with a default Red Hat installation. We also need to be sure that Apache is installed in the remote system so it can function as a backup. And let's find a window here. This should be good. So let's SSH as root to 7520. And then let's RPM query